Hello, welcome again. We are covering the subject thermodynamics for civil service means IFS and various gate exams. And the next chapter in the subject is second law of thermodynamics. In this, the first topic is qualitative difference between heat and work. Okay, so here, according to first law for a process, this is the statement. For a process applied to closed system, this is the statement Q12 is equal to del U12 plus W12. It means all the heat supplied uh, can be converted into summation of work done and change in energy. Suppose if we take Q12 as 50 kilojoule, then this del U12 and W12 can have some values, and these values can have infinite number of combinations to satisfy this Q12 equal to 50 kilojoule. Okay, but according to first law, this is your energy balance, 50 kilojoule here and 50 kilojoule here. But all the combinations are not possible. Some combinations are possible. So that is given by your second law. First law tells that energy will remain conserved. This energy will be equal to work done plus change in energy. That is your first law. But whether it is possible to have suppose value 12 as minus 1000 and its value is 1050, so that the submission becomes 50 percent. Whether it is possible or not, that is given by second law. Okay, so the statement is first point is in the article is the first law of thermodynamics states that a certain energy balance will hold when a system undergoes a change of state or thermodynamic process, but it does not give information on whether the change of state or the process is at all feasible or not. For example, for a process, first law of thermodynamics is Q12 is equal to del U12 plus W12. So if we take Q12 as 50 kilojoule, then there can be infinite number of combinations to satisfy Q12 is equal to 50 kilojoule for these two, but only Q are feasible according to second law. Okay, so that is the first example of distinction of first law and second law, or why we need second law. That example explains why we need second law. Second example is, suppose we have a bar of uniform temperature 500 degrees Celsius. Okay, so all the at all the points the temperature is 500 degrees Celsius. So if whether this bar can automatically convert into a bar having n temperature as 750 degrees Celsius and 250 degrees Celsius, so that the average temperature remains same without any external add spontaneously. Okay, without any external add, whether this bar can be converted into a bar having n temperature 750 degrees Celsius and 250 degrees Celsius, having the same energy as this bar, whether this occur or not, this is given by second law. But according to first law, this bar is having same energy, this bar is having same energy, so that can be possible. But whether this occur or not, this is given by second law. Okay, suppose if it occurs, then here we have to drop the temperature from 500 Celsius to 50 Celsius, and here we have to increase the temperature from 500 to 750 Celsius. So it means some heat will be lost from this end and some heat will be gained in this end. So all the heat that is lost by this end will be equal to all the heat that is gained by this end. That should occur. So that is possible. Here heat loss is same. Here heat as the heat gained by this end. That is possible. Okay, so that is possible by first law. But whether it will occur or not, that is given by second law. So first law cannot indicate whether a metallic bar of uniform temperature can spontaneously become warmer at one end and cooler at other end. All that the law can state If the process did occur, the energy gained by one end would be exactly equal to the lost by the other. Okay. So it is the second law of thermodynamics which provides the criteria as to probability of body's processes. Now we have come across a word spontaneity or spontaneous. Okay, spontaneous means without any external interference. So all the spontaneous processes in nature occur in one direction. Like heat always flow uh, from higher body temperature to lower body temperature. Water always flow downward. Time always moves forward. The reverse of these will not occur spontaneously, automatically. Okay. Okay, so this is the next point. The spontaneous processes in nature occur only in one direction. Heat always flow from a body at a higher temperature to a body at lower temperature. Water always flow downward. Time always flow in forward direction. The reverse of these never happens spontaneously. Okay. So here first is where heat flows from higher body temperature to lower body temperature. So here temperature difference is the driving force or the car, and the ultimate result is your heat, that is called flux or current or the effect. Okay. Next point is the spontaneity of the process is due to finite driving potential, sometimes called a force or the car. What happens is called the flux, the current, the effect. So it means the temperature difference is the force or cause and or the driving potential, and the heat transferred is the effect or flux or the current. Okay. Next point is the typical forces like temperature gradient means temperature difference, concentration gradient, concentration difference, the electric potential gradient have their respective conjugate fluxes of heat transfer. So when there is temperature gradient, heat transfer will take place. When there is concentration gradient, mass transfer will take place. When there is a electric potential gradient, then flow of electric current will take place. Okay. So these transfer processes can never spontaneously occur from a lower to higher potential. So heat will not transfer from a body at lower temperature to higher temperature spontaneously or automatically. We have to apply some external work or something extra to make it happen. So heat will transfer from higher body temperature to lower body temperature, not from lower body to higher body temperature. So there is particular direction in which all the processes will take place. So that is given by second law. This direction law puts a limitation on energy transformation other than imposed by first law. Okay, so that's why this uh, second law is needed. First law tells that heat will transfer from higher body to lower body. Okay. Oh, sorry. Heat will this amount of heat will transfer from one place to other place, and this amount of reverse can also happen, but reverse will not occur according to second law spontaneously. Okay.